Complex shaped parts are often used in applications such as automotive, medical, electronics and aerospace, amongst others. Their conventional production method is CNC machining. This method is based on subtractive manufacturing where material is removed from the solid block. Multiple steps and post-processing are required. CNC machining has its own challenges, and one of the biggest are the high investment costs. It is a time-consuming process and produces lots of waste. Also, the post-processing steps require harmful chemicals. What if you could produce complex shaped parts in a sustainable way? Introducing the CLASCO project, climate neutral and digitalized laser-based surface functionalization of parts with complex geometry.
The CLASCO project intends to replace many conventional manufacturing processes by 3 laser-based technologies, being laser additive manufacturing, laser polishing, and laser-based surface functionalization. The target is to reduce waste in manufacturing of products as well as energy and materials consuming.
The CLASCO project has 6 main targets. The first target is focused on digitally modifying the use cases for the additive manufacturing process. The goal is to develop a design with optimized topology and reduced weight without structural compromise. In this way, less raw material must be used. Additive manufacturing is a sustainable process for complex shaped parts. A laser powder bed fusion process is used. Here, metal powder is added layer by layer and the laser beam is selectively melting the powder, thus building the final product. At the end of the process, the product is removed from the rest of the powder, which is used again for the next process cycle. The final product goes into the post-processing step of CLASCO. The second target of CLASCO is focused on developing laser-based treatments for surface functionalization. It starts with the polishing of the surface.
The additive manufacturing process, a big side effect is that surfaces are porous and may have valleys, peaks, and not a great surface finish, which make them not usable for lots of application. So the SYLAS polishing process is based on remelting the surface, and so it eliminates these valleys and peaks. And after polishing, the surface is smooth and ready for a lot of application.
For structuring the surface, a direct laser interference patterning process is used. By applying different patterns, the surface can have the following properties: self-cleaning, anti-icing, antibacterial, corrosion resistant, and reduced friction. The third target is to incorporate inline monitoring, such as an infrared camera and a plasma sensor. This enables the virtual representation of the manufacturing process. The fourth target handles the AI solutions for defect prediction and prevention in real time, machine learning, closed-loop control mechanism, and the data acquisition and integration within the CLASCO machine. All developed target solutions will be applied in 5 use cases. These are a clamp for aerospace, a lever and a bracket for aviation, as well as knee and trauma implants for medical applications. Finally, the sustainability of the processes will be assessed.
A very important target of this project is to improve the sustainability of this emerging technology. Therefore, we analyze safety aspects, social risk, as well as environmental impacts and the economic performance of the conventional production and compare to the CLASCO process to improve the last according to the highest standards of safe and sustainable by design approach from the EU. Finally, we also look at gender dimensions of the project, for example, safety according to the gender.
At the end of the project, the CLASCO machine will be assembled. There are 4 main components: the surface laser polishing part, the surface laser structuring part, as well as the part for inline monitoring, and the part for machine self-learning. For more information, follow us on our CLASCO website and on social media platforms like LinkedIn.